Okay, so what are the challenges here? So the first challenge is constrained resources. So when we look at an IoT device, it's not a very powerful device. Okay, if you look at an Arduino, it cannot implement very heavy libraries. For instance, if you want to implement a very heavy cryptographic algorithm on it, it won't do it. It, it actually can't do it. So the the resources of IoT devices are constrained. First is the energy. So IoT devices would not normally would not be connected to the grid. So for example, a sensor which is remotely located in an agricultural field or even in, for example, a traffic light. So it might have to harvest its own energy, and based on that, it does its processing. But the energy, the concept over here is that the energy is limited. It does not have endless energy like other computers. So based on that, normally IoT devices would have lesser processing power. Okay, that's deliberate because if you put a very high-end processor into the IoT device, one, it becomes expensive, and the next thing is it would require more energy. So whenever we talk about IoT devices, we want them to be low cost. Okay? So maybe around $5 or something. So then again, it has resource constraints. So the third one is memory. They might not have a storage device. The memory would be very small, maybe 2 kilobytes or something like that. So if you're designing a protocol, if you're designing an algorithm or anything for IoT devices, it's very challenging because you do not have the luxury which you have on a normal computer. You have to design according to the devices. And that means that your algorithm or whatever you're designing should be efficient in terms of energy. It should not require very computationally intensive processing involved, and the memory requirements should also be low. So that becomes very challenging when you're implementing IoT devices. Okay. The next thing is they are always on 24 hours a day normally. So for example, there's a temperature sensor in a nuclear power plant. You don't want to turn it off because it's controlling a very critical unit, right? So how do you update the IoT device then? Okay, how do you perform maintenance on these devices? So that's another thing which becomes very challenging. Um, and then if something goes wrong with the computer, you can just restart it, right? But if an IoT device is controlling some critical infrastructure, you cannot say that, okay, just restart it. For example, an IoT device which is controlling a traffic signal, if it restarts, it would be chaos at that signal, right? Okay, then next one is remote location. So when we look at our personal computers, one of the idea over there is that these personal computers are physically well protected, right? If someone wants to make changes to the computer, they might not be able to access the computer physically, at least. They might have to come through the internet. But when we talk about IoT devices, they are deployed in remote locations. So one of the assumptions over there when designing protocols or algorithms for IoT devices is that an attacker or an adversary or someone else with some other intentions might have physical access to the device. Okay, so I'll explain why that matters, especially in terms of security. So I just said they are not physically protected. And the last one is because IoT devices are so cheap, manufacturers are not willing to put in a lot of money in terms of testing and updates. So you would find a lot of IoT devices which won't get updated, like in your mobile phone when for instance, if you have an Android phone or iPhone, when an update comes, you update it, and then the update normally would have a security patch or other fixes. And that's not the case with IoT device, at least most majority of the devices.